Greetings to all the viewers. The session is going to cover with the compound called ephedrine. It is the class of alkaloid and it is the part of natural product. Ephedrine, how it will be extracted from the nature, what kind of applications we can find, and what is the pathway for the biological synthesis, and how can we go for the analysis by means of advanced analytical tools. So many spectral methods are going to be implemented. Later on, laboratory synthesis will be discussed in detail, and we will go with the applications where we are going to apply the compound in general. These are the topics going to be covered in the session. The topic is regarding ephedrine. Let's go with the content called ephedrine, that is alkaloid. Ephedrine is a naturally occurring alkaloid derived from the ephedra plant. Ephedra plant you can observe over here. This is the plant where ephedrine alkaloid get extracted. It has a chemical structure similar to amphetamine. Amphetamine and ephedrine both are resembling with each other, and even norephedrine. Some extent of similarity you can notice with norephedrine as well, and is a part of compounds known as sympathomimic amines. So here, obviously, alkaloids should composed by the nitrogen. So it is a part of amine. So here, what sympathomimic amines. So the type of compound it will be. This alkaloid primarily acts as a stimulant and a bronchodilator. Stimulant is nothing but which used to enhance the activity of the brain. Brain functioning can be elevated, that is noticed as a stimulant. Bronchodilator. Bronchodilation is nothing but it is related with the lung and breathing type of disorders can be mitigated. So bronchodilation in the sense whenever windpipe used for the inhalation and exhalation of the air, so that air pumping is possible in general, and oxygen will be transported to the heart, and from there blood able to absorb the oxygen can transport to the entire organs present in the human. This is the way entire pumping process will be proceeded. In the bronchodilation is required whenever all the windpipes got contracted, where the circulation of air becomes very difficult, and they will face respiratory disorders. Breathing problem will be arised. At that condition, the contracted pipes may be enlarged. That bronchodilation property will be achieved by means of this ephedrine, and with the application treating asthma. All the symptoms, that kind of contraction of windpipe is a symptom of asthma only, where the respiration becomes a problem, especially in the cold conditions. And bronchitis, it is also the kind of lung related disorder. Lung muscles are not contracted in general, so whenever air pumping is possible, that lungs should be contracted and expanded, right? That is the general process carried. Whenever bronchitis is the disease occurred, muscles becomes very rigid and that contraction property totally disappeared. That way, bronchitis people will also served are curated by means of ephedrine. And the people who are suffering with the lower blood pressure conditions, blood pressure is nothing but whenever pumping of blood is possible, that kind of pumping rate is measured by 120 by 80. So upper limit will be 120, that should be there, and lower will be 80 will be there. That is the optimal level of the blood pressure. If that level is minimized than the described levels, that is indicated as the lower blood pressure or hypotension, we can say. So if 120 by 80 exceeded, that is called hypertension, high blood pressure will be there. So this is the way, if the people who are suffering with the low blood pressure conditions, at that phase also we can go for the medication with the ephedrine. Structurally, ephedrine is a chiral molecule. If you observe clearly, here is one chiral center will be there, another chiral center is noticed at the second carbon atom. So that two chiral portions are present within the molecule. Hence, it is the part, it is the mixture of enantiomers. Whenever chiral centers are present, obviously there is a possibility for the enantiomers or diastereomers, but the molecule is existing in an enantiomeric pair. One is a dextrorotatory and either is a levorotatory one, right? So plus ephedrine and minus ephedrine are two kind of compounds are noticed based on their orientation, and based on this kind of stereospecificity, they are also exhibiting their own pharmacological effects. So plus ephedrine and minus ephedrine both are not having equal or resembling effect on the diseased organs, so that their physiological or pharmacological activity is also varying based on their orientation matters. That's the reason why stereochemistry plays a vital role in the drug chemistry, right? So let's go with the key characteristics of ephedrine. First of all, we will look into its structure. Ephedrine has a phenylamine backbone. So here phenylamine is nothing but wherever benzene ring is located, and even amine is also present, that is the part of what phenylamine. So here you can notice the benzene ring, and here is the nitrogen, so that we can say phenylethylamine. So here in between the nitrogen and phenyl, you can notice two carbon atoms in the backbone. So that phenylethylamine backbone will be there, and upon this we can observe one hydroxyl, and an alkyl group is also present. This is the way the entire structural representation is present. And we will discuss about its pharmacology, in what way it will be helpful in the medical field. It acts as a stimulating the central nervous system, right? So entire body regulated by means of impulsions provided by the nervous system. We have the central nervous system and the peripheral nervous system, the entire brain and the spinal cord together regarded as a central nervous system, and the extended nerves from these are called they enters into each and every organ. Those are called peripheral nervous system. So peripheral nervous system works upon their own region, central nervous system having its effect in the body. So here this ephedrine is having stimulating activity on the central nervous system, increase the release of norepinephrine. So this used to release the norepinephrine into the human body. So whenever norepinephrine released into the human bodies, that able to bind with the adrenergic receptor. Adrenaline is the hormone which is present in the body. Everybody aware about that one. This ephedrine, whatever we are discussing about, is some extent resembling with this adrenaline. Adrenaline is the hormone which is responsible for the rate of blood pressure, higher blood pressure, lower blood pressure. That controlled by means of this adrenaline gland, we can say. So the norepinephrine, whichever secreted, whichever released, able to bind up with this adrenergic receptoric sites, giving rise to the increased heart rate. That's what adrenaline having the regulation over the heart pumping, so that blood pressure got maintained by means of the hormone called adrenaline. The people who are having higher secretion of the adrenaline are suffered with the high blood pressure conditions. Right. So here, whenever this adrenaline secretion got improvised, so that heart functioning will be will become a normal one, and blood pressure got maintained in a proper manner, and the bronchodilation is also possible. Bronchodilation refers to whenever the windpipe or lungs related air pipes will be there, no, they will be expanded, so that the air circulation becomes very normal in order to avoid that respiratory disorders. These are the kind of applications we can notice in the medical grounds regarded for ephedrine drug. Then let's go with another usages for ephedrine. Ephedrine used in the medical field to relieve the nasal congestion. Nasal congestion is nothing but whenever this nozzle pipes got blocked by means of the secretion of mucus over there. So large secretion of the mucus that used to completely disturb the circulation of the air, so that breathing becomes very problematic. At that condition, the nostril congestion is totally curated by means of this ephedrine. And treat hypotension, right? So just now we discussed about low blood pressure is regarded as hypotension whenever 120/80 level is minimized. Lesser level than that one, that is regarded as a hypotension. And this hypotension is commonly observed whenever the people are subjected to the anesthesia at surgery conditions, especially whenever surgeries are conducted. We need to go through the anesthesia in order to pass are the functioning of the brain and the pain conditions. That time we become unconscious for some time, temporarily unconsciousness induced by this anesthesia. At the time, there is this kind of side impact which used to give the lower blood pressure. So breathing, that blood pumping will become very slow, and at the time that heart rate is also lowered. So in order to avoid this condition, we have to go for the medication by this drug called ephedrine. So, and in some cases support the respiratory functioning, and the breathing problems also mitigated, especially under asthma conditions and bronchitis. Bronchitis is nothing but complete contraction of lung muscles, so that expansion and contraction, that means flexibility of that lungs totally lost. So these conditions will be effectively curated by means of this drug called ephedrine. Then let's go with where can we find this drug called ephedrine, from where we are going to extract this one. Being it is a natural product, we have to go to the nature. Natural sources for the ephedrine, it is found in the plant from the genus Ephedra, notably Ephedra sinica. Ephedra sinica is a plant you can look over here, and it is traditionally used in the Chinese medicine. So the origin of this medicine is we noticed in China, and at their native term, it is regarded as a mahang, right? So Ephedra sinica is the scientific name imparted for this natural product called ephedrine, from which we are going to extract this one. And let's see what is the legality and the regulation for this one. It is not having open access to each and everyone, rather it is some extent controlled, regulated one because of its misusage, right? Due to its stimulant properties, and ephedrine is regulated in many countries. Usage under observation, usage under controlled way is observed for this drug called ephedrine. Let's go with the nomenclature of the compound. IUPAC name of the ephedrine. IUPAC denotes International Union for Pure and Applied Chemistry. According to the IUPAC, the naming is provided in the systematic manner. Ephedrine is named as 1R2S, 2-methyl-amino, 1-phenyl propane, 1-ol. The skeletal structure is regarded with the 3-carbon chain, where we can notice side chains like N-methyl one side, phenyl in either side, and absolute configuration is also measured over first and second carbon atoms, being 2 carbons are accompanied by the chiral center, so that 1R2S is the absolute configuration. RS notations are also provided. Let me repeat the IUPAC name of the compound once again. 1R2S, 2-methyl-amino, 1-phenyl propane, 1-ol. So this is the IUPAC nomenclature. Let me elaborate the name in detail. Here is the breakdown of the IUPAC naming for the given compound called ephedrine. 1R2S. This notation specifies the stereochemistry of the ephedrine, being first and second carbons are chiral, so that absolute notations are rectors. S means sinister. This notations also provided. It indicates ephedrine has 2 chiral centers. At the first position, R rotation or configuration we can observe. At the second carbon atom, S configuration is noticed. RS is the notation over first and second carbon atoms. And at the second carbon, if you observe at the second carbon, there is a nitrogen upon, you can notice one methyl, so that we can say on the second carbon we have N-methyl. N-methyl amino. So this N-methyl amino is located on the second carbon atom. And first carbon atom, if you observe the first carbon atom, there is another bulky functional group called phenyl. If benzene ring is present, C6H5 is designated as a phenyl. So that phenyl is located on the carbon 1. Then entire skeleton is having 3 carbon backbone, and another functional group is also there on the first carbon, that is hydroxy, so that the parent chain will become propane, and being it is a hydroxy, so that we have to regard it as a propanol, right? So propanol is provided for the skeleton of this compound, and the entire name is regarded as, at the first carbon we have R notation, and the second carbon S notation, and the second carbon we have N-methyl amino, first carbon we have a phenyl, and backbone is sorry, backbone is a propane, and the first carbon is having hydroxy, so that propanol. Propane manol is also the proper representation of this IUPAC nomenclature. This is the entire description regarding IUPAC naming of the given compound. Let's go with its extraction. How can we go for the extraction? Being it is a natural product extracted from the plant called Ephedra and how can we extract this ephedrine compound from this Ephedra plant? Ephedrine can be naturally extracted from the plant called Ephedra genus, commonly Ephedra which is known for its high concentration of the alkaloid. Here is an overview for the natural extraction process. What are the steps involved in this entire extraction process from this plant? First of all, we have to go for the plant collection. We have to identify this Ephedra plant. Later on, we have to collect, harvest mature ephedra plants, particularly the stems. Stems, higher concentration of ephedra is present, so the stems to be collected. Later on, they subjected to drying process, because in order to avoid the microbial growth, fungi or else any other bacteria or virus, in order to avoid the growth of these many microorganisms, entire stem collected from this Ephedra plant to be dried in a proper way. Later on, grounded into a fine powder in order to make the greater extent of the surface. More the surface, obviously, more will be the reactivity, more will be the possibility for the extraction process, right? That's the reason why powdered or grounded material to be taken, and dried material to be taken and finely grounded into a powder in order to rise the surface area. So whenever surface area is improved, so that extraction is more efficient. That is the way powdering process got carried. Later on, we entered into the important step called extraction of alkaloid. In order to extract from that grounded powder, the solvent extraction process to be subjected at that condition, either ethanol or methanol, suitable solvent to be added. These are the most common solvents in the organic chemistry, so that we can dissolve either in the ethanol or methanol, so that the alkaloid will slowly extracted into this alcohol part, and remaining whatever this organic solvent suspended material can be discarded. So this is the way extraction process got carried. Later on, place the powdered ephedra into the solvent, allow it to steep for the several hours. So whenever we are mixing the powdered one with this solvent, so that after thorough mixing, that should be allowed for some time in order to make the entire process of extraction. So entire ephedrine material to be taken into this solvent part, that requires the longer time, so that we have to keep that entire material aside for longer duration. Mild heating is also required. That used to improvise the efficiency of the extraction. Whatever leftover alkaloid is there within that crude, so that also slowly coming into a liquid part, and extraction will become more efficient upon a warming condition. So this is the way extraction process got carried. You can see the separating funnel over there, and it is fitted with this fitted with this stand, and here funnel, sorry, round bottom flask was taken, into which you are going to extract, you are going to separate the mixture, and extract, crude extract will be taken into this round bottom flask. Acid base extraction. After getting the material into a solvent, later on we have to go for ephedrine. So always everybody aware that in order to measure the compound as an alkaloid, the essentiality will be presence of nitrogen, right? Obviously, nitrogen will impart the basic nature to the given compound. Whenever the compound is basic, so mild acid should be, sorry, small extent of acid should be added over. So dilute acid like hydrochloric acid to be mixed in order to make neutral. Whenever basic compound is added with this hydrochloric acid, what happens, it turned into a kind of so we are making into a neutral one. If excessive hydrochloric acid is added, that is becoming like a salt form will be generated, that is recorded as a ephedrine hydrochloride. So this is the way acid, that is hydrochloric acid, a diluted one, should be added in order to make liquid into a solid form, that is into a salt form. Filter out the plant material, leaving behind the solution containing the alkaloid. Whatever nitrogen containing ephedrine is there, that will reacted with hydrochloric acid, and the leftover impurities can be easily discarded, because they are not the part of this reactive compound. So that it's very easy to go for the separation. Later on, whenever we are becoming the entire compound into a salt one, now it is the time to add with the base. Whenever base is added, what happens? It will become a neutral one. So acidified compound now treated with the base, so that sodium hydroxide will be added in a dropwise manner, so that neutral compound will be generated, that ephedrine will be separated over there, making the less soluble water compound, but more soluble in the organic compound. So now whatever ephedrine is separated as a neutral compound, that is coming as a slight water soluble compound, but it is more prone to dissolve in the organic solvent, being it is a kind of organic compound. More organic content is there in that, so that organic solvents so that means organic solvents more prone to dissolve the organic compounds in that. So that is the way basification, giving rise to neutralization of excessive acid present in that, and the compound ephedrine will be separated and that extracted into the organic solvent. Then solvent partitioning. Non-polar organic solvent you may take here. Chloroform, either dichloromethane can be taken to extract the deprotonated form of the ephedrine. So being the compound is now organic moiety, so either of the solvent we can choose for this kind of extraction, chloroform or else dichloromethane can be taken, in which the ephedrine will be dissolved. Whatever non-polar solvent solubility is not there, those will remains in the solid form only. Again, here is the condition, here is the step, you can discard that also. So in these many steps, whatever crude compound taken initially, slowly we are going to purify in a step-by-step manner, and we are getting extracting in a higher concentration. This is a part of concentration. Right. Shake the mixture very thoroughly. After dissolving in this chloroform, now we are going to shake the mixture in order to make the more aggregation among the species. Separate the organic layer containing ephedrine. So after mixing thoroughly into the organic layer, into this chloroform layer, the ephedrine will be extracted, and into the aqueous layer, whatever leftover crude and other impurities, that will be remained in the aqueous part. So this is the way separation is carried in the separating funnel. Later on, we can go for evaporation followed by crystallization. Obviously, any solvent you are going to choose, the solvent generally contains lower boiling point. By simple warming, or else by simple placing in an open air, that slowly chloroform, everybody aware that whenever chloroform placed in the open air, slowly it will be disappeared, being it is a highly volatile. That's the reason why it is used as the powdered anesthetic agent, right? being it is a highly volatile in nature. That's the reason why when chloroform used over here, that simply evaporated without any technique. When you are taking into a petri dish, simply that will be evaporated. Whatever ephedrine left over, being it is a high molecular weight, so it will exist in a kind of highly regular crystalline form. So crystalline compound will be appeared, that is ephedrine here. Now, and next step we are going with the recrystallization. Already we got the crystals. We will step into another portion which is called a recrystallization. Recrystallization means for the high purity. In order to obtain the compound in high purity, we have to go for the recrystallization process. For that purpose, charcoal and a suitable solvent, either ethanol or methanol, get mixed over. Simple warming the compound, the impurities will be grasped by the charcoal, and the solvent ethanol will be accompanied by this ephedrine. This is the way we are going to filter the compound under suction conditions in order to make higher rate of separation of the compounds from the liquid. So whatever liquid portion collected can be placed in a petri dish, and that will be evaporated and recrystallization, giving the high purity of the compound. So some adsorbable materials got removed by the charcoal over here by the process called recrystallization. Later on, we have to go for the purity check. Purity testing will be carried. So that quality testing is conducted by either thin layer chromatography or else high performance liquid chromatography. In either way is also their mass spectroscopy. Either TLC or HPLC mass spectroscopy subjected in order to measure the quality of the given sample compound called ephedrine. This extraction method is the ephedrine in the free base form, which can be converted into various salts. You may prepare. So this is ephedrine hydrochloride is commercially available trade compound. Trade name. So ephedrine hydrochloride is a stable trade name compound we may found in the pharmaceutical usage. So whatever the compound for the stimulation, whatever the compound for the curation of asthma. So in these conditions, ephedrine hydrochloride is the trade name which is available for the pharmaceutical applications. After getting the extraction process entirely, we will go for its identification, whether the compound we extracted, the entire process we carried, but now we have to confirm whether the compound is same what we are expecting or not. For that purpose, we have spectroscopic methods. Unknown compound can be placed in the spectrophotometer, and the light conditions we are going to identify the compound in general. The analysis of ephedrine by the spectroscopic methods, each are revealing different structures, functional formations about the compounds. Here is an overview of how to analyze the ephedrine using the common spectroscopic techniques. How many techniques we are going to employ over here, and what way the kind of data we are obtaining by these many analytical tools in order to confirm the ephedrine skeletal structure. Let's go with the first technical tool called infrared spectroscopy. The objective to apply this IR spectroscopy to confirm the ephedrine structure. Whatever functional groups present in the given compound, ephedrine to be identified by means of their vibrations, stretching vibrations to be noticed over here, characteristic stretching vibration band. This peak denotes what kind of functional group is present. According to the data provided, OH group is present in the compound. You already noticed the compound is accompanied by OH functional group, and neither amine is there. And so the IR spectra is basically meant for the functional group identification. This data is clearly provided by this IR spectroscopy. Let's see how can we reveal the functional group analysis by IR spectroscopy. For OH stretching, we notice the peak at 3200 to 3600 centimeter inverse. When we are plotting the graph between the wave number versus relative transmittance, this kind of peaks you can notice, and all the wave number values are measured in centimeter inverse values. And 3200, 3600 characteristic peak meant for the presence of hydroxyl functional group. If you observe the peak around 33 to 3500, that is for what? NH stretching. So OH and NH are closely, very close to each other, so that here two different peaks you can clearly observe. One is for OH, another is for NH. Both are present in the compound. And there is another peak you can clearly observe, 2800 to 3000 centimeter inverse, that is responsible for the presence of carbon hydrogen bond stretching. Right? CH bond stretching vibration is noticed at the range of 28 to 3000 centimeter inverse. This confirms the presence of CH stretching. And there is another possibility, right? Whenever CN is there, whenever CH is there, NH is there, OH is there, there is a condition for CN as well. So that CN stretching is also appeared somewhat it is near to the fingerprint region, 1200 to 1350 centimeter inverse region, that is responsible for CN stretching. This is the way IR stretching confirms the presence of OH functional group, that is hydroxyl, and another NH amine is also present within the compound. This data is given by IR. Let's go with the NMR. NMR again, you can measure the environment of hydrogens, or else you can measure the environment of carbons. That means nature of carbon, nature of hydrogen. So that two kind of NMR spectroscopy we are going to deal with. First is about the proton NMR spectroscopy, that is called H1 NMR spectroscopy. H1 NMR spectroscopy is meant for the nature of hydrogen, so that arrangement of the compound most higher extent, larger extent can be revealed by means of this one. According to the HNMR spectroscopy, we can observe the peaks, and these peaks are clearly observed on this delta scale. Hydroxyl protons are appearing at the range of 4 to 5 ppm. This is the characteristic peak for hydroxyl. If you observe this hydroxyl, that is around 3.65. This clearly observe 3.65 region, that OH peak you can notice, and aromatic protons will be there. If you observe the aromatic protons are at the range of 7 to 8. Wherever 7 to 8 ppm range will be there, that is simply the compound is aromatic. This is the distinctive characteristic peak, complex peaks we can notice in the range of 7 to 8, that regarded for the aromatic hydrogens. And here also another NH group is there, so that this hydrogen is giving around 2 to 3 ppm. 2 to 3 ppm peak is meant for 2 to pp 2 here, very little peak you can notice, that is meant for the hydrogen bounded upon nitrogen. So NH proton is giving a peak in the range of 2 to 3 ppm. Alkyl protons will be there. Alkyl proton, if you observe the compound, two distinctive alkyl groups are present. One alkyl attached to the carbon, another alkyl attached to the nitrogen. This gives the two distinctive peaks, and which are clearly observed in different regions. Whenever carbon bonded to carbon, that is the shielded zone. Carbon bonded to nitrogen, deshielded zone. Because electronegative nitrogen used to shift the value somewhat lower field. That's the reason why when compared to this methyl is appearing 3 to 3.26 ppm range, and this methyl bounded with the carbon giving at the range of 1.12. So 1.12 responsible for CH3 of carbon, and 3.26 responsible for the CH3 of nitrogen. This is the way distinctive peaks we can clearly observe. Proton NMR gives the much more information regarding the entire skeletal structure of ephedrine. Let's go with the C13. C13 will reveal the nature of the carbons, what nature we have. Carbon environment can be predicted by means of the C13 NMR spectra. According to C13, aromatic carbons are distinctive at 120 to 140. If protons, if you observe, 7 to 8 ppm is common. In terms of carbon, it will be a range of 120 to 140. This 120, 140 peaks are present. The compound is obviously aromatic, we can say. Then Carbon bearing hydroxyl. If a carbon containing hydroxyl is there, that peak will be appeared at 50 to 75. You can clearly notice 50 to 75 peak, this peak responsible for hydroxyl. And methyl and methylene are there, no? These peaks will be in the range of 10 to 40. So in the range of 10 to 40, here two different peaks for two different compounds. So one is for 14 methyl and another 34 for another methyl and the nitrogen. These two peaks corresponds to methyl only. Then this is the way nature of the carbons can be distinguished by means of C13 NMR spectra. And what is the significance of NMR? Why we have to observe, why we have to analyze the compound by NMR? NMR provides us insights into ephedrine structure, verifying the connectivity, chemical environments, and hydrogen carbon nature will be prevailed by means of C13 NMR spectroscopy and proton NMR spectroscopy as well. This is the way NMR data was analyzed. Later on, we entered into another analytical tool called mass spectroscopy. It will give the information regarding the molecular weight of the compound and how can we go for the fragmentation. By means of fragmentation, so the clear analysis of the compound will be analyzed and purity of the compound is also measured, right? Objective to measure the mass spectroscopy is it can help to identify the molecular structure and how the fragmentation pattern, how can we break down the compound into simpler fragments, right? So here molecular ion peak, M plus ion peak will be appear at 165 M by Z, the mass by charge value. That is for ephedrine that clearly noticed over here, and fragment ion peaks are distinctive at 58 and 121. This is the way we can go for the fragmentation. Whenever fragmentation got carried, so that it is very easy to make a complex component a simpler species, so that analysis is somewhat easiest one. This is the way mass spectroscopy analysis carried. Later on, we entered into another segment called ultraviolet visible spectroscopy. UV visible spectroscopy gives the peaks. These are very broad peaks, and the graphs are plotted between wavelength versus absorbance. The data related with the UV visible will be whether the compound is having conjugation, double bonds are internal or external, exocyclic or endocyclic, or else there is a kind of aromatic system present in the molecule or not. This kind of data and the number of cyclic rings present, entire data will be given by this ultraviolet spectroscopy. But the compound is not having that enough functional groups over there. So here only the possibility will be 200 to 220 nanometers of the range in the ultraviolet visible spectroscopy. That is corresponding to the phenyl, presence of aromatic ring over there. And the external double bonds may not be present. And so many ring systems also not there, only one ring. One benzene ring is located. That's why only one corresponding ring we can observe in the range of 200 to 220 nanometers. This is the way you can notice the strong lined bond indicates what presence of the phenyl group over there. So UV visible is meant for the diagnosis of the ephedrine, that will give the aromaticity of the compound, whether the compound is aromatic or not. That distinction we can draw by means of this UV visible spectroscopy. Each of these techniques, whatever we observed, whatever we are discussing, these many examples, these many different ways. So all together used to give the comprehensive structure of this ephedrine. Individual spectroscopy may not give the 100% data regarding the entire skeletal structure of the ephedrine. Rather, we have to compile all spectroscopic techniques so that the entire information regarding the ephedrine will be drawn over here. So what kind of linkages will be there, what molecular weight we have, what functional groups we have, what kind of bonding environments noticed within the molecule, entire data is provided by these many spectral analytical tools. By this, the part called analysis completed. Now we entered into biosynthesis of ephedrine. Is it possible to biosynthesize this ephedrine molecule? Ephedrine is biosynthesized in the plants. How the biosynthesis is carried? So now we gone through the extraction. Already ephedrine is there in the plants. That part we extracted. So whatever we extracted, we conformed by placing into our different spectral machines. this part we finished, right? Now what we are going to observe is how this ephedrine developed within the plant material. What is the chemical mechanisms within the biological things? That part we are going to see, that is called a biosynthesis. How it will be developed, how it will be synthesized within the plant. In order to observe the pathway for the synthesis of this biosynthesis of ephedrine, we have the starting material, precursor material called L-phenylalanine. L-phenylalanine is a precursor. Precursor means the material which used to synthesize any other one, which is the starting material, is said to be a precursor. This L-phenylalanine, L is the kind of configuration, we can say. So L-phenyl, all kind of amino acids are L configurated only, right? So L-phenylalanine was taken. This is alpha amino acid, right? Amino acids as a starting material for protein synthesis. Here also we are using same amino acid for this ephedrine synthesis, right? So that L-phenylalanine was taken as a starting material, and it will be converted into phenyl pyruvic acid. This is the phenyl. This is a pyruvic acid. Phenyl pyruvic acid will be generated starting from this alanine, phenylalanine. Here, in order to make this biotransformation, we have to use the enzyme called PAL, phenylalanine ammonia lyase. Let me repeat, phenylalanine ammonia lyase. This is a kind of enzyme which used to transform this phenylalanine into phenyl pyruvic acid. So this is step number 1 in the biosynthesis process. Whatever generated, whatever phenyl pyruvic acid formed, now converted into phenyl acetyl carbinol. Phenyl acetyl carbinol will be generated by means of series of reactions. We are not supposed to go for only one step. Rather, series of reactions got carried. We have to go for the decarboxylation, later on reduction got carried. So many chemical changes occurred within this conversion. So finally, L-phenyl acetyl carbinol will be generated. Whatever L-phenyl carbinol is generated, further subjected to the process called reduction under enzymatic conditions. Entire process carried within the plant, right? So that we can say it is a biotransformation, right? Enzymes will take into the part where enzymes are used to reduce the compound, this acetyl carbinol. Wherever wherever ketone is there, that ketone transformed into a NH2 functional group. Simply this ketone now converted into a NH2, right? So for this purpose, we need to go for first reduction, later on amination. That means reduction followed by amination is required for converting this phenyl acetyl carbinol into norephedrine. So whatever compound generated here is called norephedrine. Norephedrine is one step away from this ephedrine compound. Only the difference is we have to make this NH2 into a kind of secondary, that an alkylation is required to be done. That norephedrine to be subjected to enalkylation. In order to make this enalkylation process, that to be treated for the methylation, in order to methylate adenosyl thionine to be added. Whenever norephedrine added with methylating agent, so that we will get the N-methylated product over here, that is ephedrine. This is the entire roadmap where the all chemical reactions are provided for the biosynthesis of ephedrine. L-phenylalanine was taken. L-phenylalanine subjected to protecting this amino functional group. Later on, we will achieve the pyruvic acid. Pyruvic acid subjected to decarboxylation. Decarboxylated material transamination is carried over, so that we will get NH2 functional group over there. And this NH2 functional group, whatever generated here, ketone is converted into hydroxyl, which is called norephedrine. Norephedrine subjected to SEM, that is a methylating agent, so that N-methylation got carried on this, giving rise to the ephedrine. This is the product what we require. In another pathway, and another subsiding way, pseudoephedrine is also generated. That is not our subject. We are only concentrating upon ephedrine synthesis. Let me give the conclusive steps in this biosynthetic pathway. Initially, phenylalanine was taken, that will be transformed into phenylpyruvic acid. Phenylpyruvic acid further turned into phenyl acetylcorbinol. Phenyl acetylcorbinol now reduced into a norepinephrine. Norepinephrine is methylated to giving ephedrine as the product. These many steps, 4 steps are required within the plant in order to convert phenylalanine into a ephedrine molecule. This is a biosynthetic pathway. Now, we are going to synthesize same material in the laboratory. Same material to be synthesized in the laboratory, starting from benzaldehyde. Benzaldehyde will be a starting material. Starting from benzaldehyde, we have to go for L-phenyl acetylcorbinol. L-pack to be synthesized. L-pack will be the L-phenyl acetylcorbinol is a key intermediate within the reaction. The starting material will be a benzaldehyde. Intermediate will be a L-phenyl acetylcorbinol. Right? Let me show the entire process. Benzaldehyde to be taken, that benzaldehyde further biotransformation gate carried over. So whatever aldehyde is there, that turned into a hydroxy, and the acetyl group is added on this carbon atom. So phenyl acetylcorbinol, what we just saw, the key intermediate that is generated. This phenyl acetylcorbinol, whatever generated L-pack, that to be subjected to reaction with methylamine. Methylamine will be treated under microwave irradiation condition. This is purely called a green reaction pathway. Under these conditions, ketone will be condensed with this amine, so that imine will be generated. That amine will be turned into imine. Simply, we have to go for this reduction by means of sodium borohydrate under microwave conditions. Imine now added with the hydrogen, giving rise to a saturated compound called ephedrine. Very simple pathway you can proceed within the laboratory. Though it is a laboratory synthesis, but it is called a green reaction pathway, giving rise to ephedrine as the final product. By this, laboratory synthesis segment got completed. Now we entered into next most important part of the session called applications. These many topics discussed till this time, but whatever this compound is useful, that topic is most important to be discussed. Ephedrine has several applications due to its stimulating property, bronchodilation property, and both medical and research field, it is most important compound. Some primary applications are mentioned over, medical applications we will discuss about. Respiratory conditions to be elevated or enhanced by means of this ephedrine. Whatever respiration conditions, if you observe this is a kind of windpipe where inhalation of and exhalation of the gases are possible. Whenever muscles are totally contracted, air circulation becomes totally restricted in this. Air circulation may not be possible. So this is completely contracted. So there is no possibility for the air circulation. So the respiration is very difficult to process over there. Whenever we are taking this inhaler is used with this ephedrine as a drug. Whenever ephedrine is inhaled inside, that used to enhance the size of dilation of this windpipe. Whenever dilation is possible, circulation of air is becoming more easy, more convenient, so that kind of respiratory disorders will be mitigated by means of this ephedrine. So muscles will be relaxed, muscles will be elongated. Enlarged muscles used to circulate the air in a proper manner, so that respiratory conditions will be uplifted. And decongestant. Decongestant means whenever nostril congestion is possible. Nostril congestion is nothing but whenever our nose totally blocked by means of mucus. Right? Some people in some conditions, some seasons, especially in the winter season, the people will suffer with the cold conditions, right? Where that mucus will be secreted, and that breathing will become problematic over there. That is called a nostril congestion process. So decongestant is nothing but when we are applying this ephedrine, the entire mucus secretion will be stopped, and the nozzles will become very clear, and pumping of air becomes very transparent. That kind of decongestant activity is also there for this drug called ephedrine. Next is about hypotension. Hypotension is the condition whenever people are suffering with the lower blood pressure condition. Pumping is very slow than the optimum level. Whenever we are having 120 by 80, that is the optimum required level for the healthy adult human, right? So if the levels are less than that, hypotension is the condition that people are facing. So heart pumping rate is very slow, that used to lower the blood pressure, so that will give a very serious impact, severe impact will be there. In order to avoid that low blood pressure conditions, we have to go for the medication called ephedrine. Ephedrine used to enhance the pumping of blood, blood circulation will be enhanced, so that blood pressure will be regulated, right? And another condition is called narcolepsy. Narcolepsy, we can say. Narcolepsy is nothing but the people who are having higher tendency for sleeping. So disorder, that means high, more hours they will spend for sleeping only. That is called narcolepsy. So at that condition, we have to go for the stimulating drugs, that is called ephedrine. The people who are suffering with this narcolepsy can be treated by means of this ephedrine. So it used to enhance the activity of the brain. Central nervous system activity will be elevated, so that narcolepsy conditions will be mitigated. And another application will be weight loss in the athletic performance. So how it used to lose the how it used to helping in weight loss, because it used to promote the thermogenesis. Thermogenesis is nothing but within the human organs only. What heat will be generated. When heat is generated, what happens? Burning of calories becomes more convenient. Whenever calories are burning, fat will be totally burned. Fat is nothing but extra deposition, extra food or extra materials, whatever present, we are going to store in the form of fat only, no? So that entire fat or else cholesterol will be totally dissolved or else burned by means of this high temperature or high heat conditions which are generated by means of ephedrine. That is the way. When calories burnt, what happens? Obviously fat burning is possible. Whenever fat burning is possible, weight loss is obvious in that condition. So athletes can lose weight by means of this ephedrine drug. And another is called endurance boosting. Endurance is nothing but the people who are having higher energy for longer time. So they are able to survive, they are able to secure their energy for longer time, active for longer time. That is called endurance property. That energy restoration, energy conservation, and energy generation is possible by means of the drug called ephedrine. Ephedrine is the stimulant effect. Ephedrine is having stimulant effect. It used to enhance the energy levels of that person, particularly when they are participating in the athletics. So at that condition, they require the instant energy, and a long lasting activeness is also required. At that condition, we can conveniently apply the drug called ephedrine, so that it is classified as a performance enhancing drug. Ephedrine is regarded as a performance enhancing drug. It used to enhance the performance so that the person will become more active. And another application will be a chemical research. In the chemical research also, we can apply this ephedrine, being it is of two chiral centers accommodated into the molecule. At first carbon atom and second carbon atom, both are mentioned with the star mark. And these stereo centers are responsible for the enantiomers over there. And enantio selective synthesis we can go for, so that researchers will put more efforts in order to go for the specific synthesis of one isomer, because their pharmacological effects are not similar. Plus isomer, minus isomer exactly not having same kind of physiological effects. That's the reason why enantio selective synthesis is a kind of high priority for these researchers in order to go for the selective stereoisomer, whichever used in the effective curation of the diseases. That's the reason why the chemical research of this ephedrine is most important. It serves as a starting material in so many compounds, especially in order to make the chiral compounds where stereoisomerism plays a role in that condition. This will be a starting material in order to make that kind of complex molecules. So this is the way chemical research also accompanied by ephedrine. And pharmaceutical synthesis, what way it is applicable in the pharmaceuticals, in the medical field, how we are going to use, as already we discussed, it used to give the bronchodilation, low blood pressure will be regulated, and asthma conditions will be regulated, and sleeping tendency will be mitigated, stimulation property will be enhanced, and high energy, high activation will be provided by means of this one. In addition to all these, it used in the precursor for various compounds synthesized to eradicate allergies. Various kind of allergies will be there, no? Whenever the people are suffering with the allergies, at that condition also ephedrine used. Ephedrine and its derivatives, its further auxiliaries can be utilized in order to mitigate these allergies, so that allergy repellent property is also present for this compound called ephedrine. Now, in another segment called traditional medicine, without making any medicine, just a crude product taken from the plant, and as such, it can be utilized. Most of the tribal people will go with the same medication only directly. They used to get the plants and they will crush them, and those plant extracts only directly consumed, which is called a traditional medication, right? In traditional Chinese medicine, ephedrine containing ephedra extracts. Ephedra sinica is the plant we already aware about, from which ephedrine can be extracted. So that ephedra is called mahang in their native language. From that, they used to extract the juices, and directly they used to consume for the respiratory conditions. So they also were, though they are not having this extent of scientific knowledge, but they consume these kind of plant juices to eradicate the asthma conditions and cold conditions, any respiratory disorders they are suffering with. This plant extract directly consumed as a traditional medication. So this plant directly used to crush, and alkaloid is consumed, and ephedrine itself shows the effect, but they don't know about this compound, but they are effectively using again is the asthma and cold conditions for respiratory disorders. This is about the traditional medication regarding the ephedrine. By this, we entirely completed the session where we discussed about what is the origin for the ephedrine, how can we go for the extraction, what way we can confirm its structural skeleton, and biosynthetic pathway can be detailed discussion provided here. Later on, we entered into the laboratory where laboratory scale synthesis is also discussed in detail. Very simple method is provided by the scientist. And finally, we gone through how many applications we can notice for this ephedrine. Hopefully, the session is very informative, and thank you very much for your patient listening, all of you. And the session is conducted by the Dr. Kavita Kottireddy Kotam. Thank you very much for your patient listening.